Good day, ladies and gentlemen. This is Sarah van Grinnen, aka Mr. VG. I'm excited, I'm stoked, I am happy to be here with you today. Because in this video, we are going to look at mathematical reasoning and how it applies in mathematics. So, in other words, when you get those exam questions or those tough questions at home, how am I going to apply those three basic techniques? The gungho approach, running into the problem, mining, where you dig and dig and dig and dig and dig into the scenarios or into the information given, and the monkey behind the mountain, where you look at the end in mind and you look at those things that stand in the way of getting there. So buckle up, sunshine. Today we're going to be in for a bumpy ride, but it's going to be awesome. If you haven't watched the videos previously, like about the gungho or mining or the monkey behind the mountain, please, I encourage you, go and watch those videos. Make it your own in here so that you are able to solve life's problems. Let's start with the gung-ho approach. A gung-ho approach is beautiful when we're just trying to solve X. Or when they give you those trigonometric sums, they say simplify without use of a calculator. Guys, the beautiful thing about these kind of questions are, number one, you can score marks and time. Because you can, kind of just run into it without thinking too much, meaning those real thinking questions, you'll have more time for them. When we're talking about mining, there's very few times in maths where there's pure just mining. But I found an example for you. This example reads, draw a labeled sketch of y equal to s times b to the x plus q, where s is smaller than -1, b is greater than -s, and q is larger than 0. Let's just quickly pause for a moment. Let's dig in, guys. What type of graph is this? It's an exponential graph because of the power of x. S smaller than 1. Ooh, what does that mean again? Well, it means that the graph lies below your asymptote. Then we look at the nasty little bugger, b greater than -s. Oh man, how do I solve that? My little bit of advice. Choose a value for s. Like s is -2. Well, then b must be greater than -2. Well, that means b is greater than 2. Why is this important? Because there's a little bit of theory which says if b is greater than 1, the graph is going away from the asymptote. Last but not least, q is greater than 0, which means the asymptote lies above the x-axis. So in other words, the graph looks like this. Now, very seldom in mathematics, I'm being honest with you, will there be a pure mining type of sum. Usually, there'll be a mining going over to a monkey behind the mountains. Now, when we talk about going over from mining to the monkey behind the mountains, the type of questions that you are looking for is specifically geometry, Euclidean geometry. Now, for those of you that haven't done grade 11 Euclidean geometry with circles and stuff, this will maybe be really freaking you out and be really weird for you. So please just look at what I'm going to do. And then when you've done Euclidean geometry later on, you'll be able to do exactly what I do. So let's start by mining into this question. In the diagram below, H, E, N, and G lie on circle with center O. Ooh, that's important because there'll be radii. And where there are radii, there's usually an isosceles triangle. So G1 and 2 is equal to N1. Then I look at theorem 2. Theorem 2, which says the angle at the center, so angle O, is twice angle E2. Again, for those of you that haven't done Euclidean geometry yet, just stick with me. You'll do this theory a bit later on this year. Next up, I'm going to have a look at NC being a tangent. If NC is a tangent, well then the radius is perpendicular to that tangent. So N2 and 3 is 90 degrees. There are not two tangents from the same point. So therefore, theorem 8 is out the question. Theorem 9, well, theorem 9 says that angle N3 is actually angle G1 because of tan chord. Ooh, I love this, guys. Ooh, I love tangent. So let me just go on to the next bit of theory. Next up, they tell me that GB is parallel to NC. So I look at my grade 8, 9, and 10 theory. If GB is parallel to NC, well, E1 is P1 because of corresponding angles. So is B1 and C. Also, E2 is equal to N3. Oh, that's beautiful because that means G1 is also X. Last but not least, I'm going to have a look at HG equal to HE, which means, again, I've got an isosceles triangle. G2 and 3 equal to E1. Now, at this moment, I just want to say, I haven't really looked at cyclic quads yet. I'm not going to look at cyclic quads now, but I challenge you, find the equal angles. So now we've done our mining. We've done all the information we can get. Let's go over to the monkey behind the mountain. Prove that Gn equal to Ne. In other words, prove that that side is equal to that side. Now I go and I think, how can I do that? How can I prove an isosceles triangle? Well, for me to prove an isosceles triangle, the angles opposite them must be equal. Oh my goodness! E1 must be equal to G1, but they're both X. So I can now just write down y is E2 X, y is G1 X, and I've got it. Boom! Now I know I make it sound ridiculous and ridiculously easy. But this is if you know your theory and you start by mining and move over to the monkey behind the mountain. I encourage you later on when you've done the geometry, please revisit this slide and see what I say and why I'm saying it. Last but not least, we are going to have a look at when do I go from the monkey behind the mountain to mining. In other words, when do I go from looking at my end result to what information was I given? Now for this example, I chose this one which says, if it is given that the equation has no real roots, determine the possible values for k. This means my monkey is k. Now the mountains that's standing in the way, first of all, is that they want me to have no real roots. In other words, delta must be smaller than naught. But for me to get delta, I need to have b squared minus 4ac. Now for me to get b squared minus 4ac, I need to first have the equation equal to naught. But I've got it. The equation is already naught. So a is 2, b is 3, c is k. I can substitute that into delta, make it smaller than naught, and solve the monkey. Now, ladies and gents, this is important. Most of the time in mathematics, we are going to use the gungho approach, and then we are going to use mining going over to the monkey behind the mountains. So I encourage you, to revisit this quite often as you prepare. Revisit this video. Make sure that you get this. Make sure that you understand this. And if you're struggling, please let me know. And I will help wherever I can. Ladies and gents, you can do this. I believe in you. This is Mr. VG signing out. My superheroes, go and have a wonderful rest of your day and tune in to our next video, which is about problem solving in physical sciences. Have a beautiful evening, beautiful morning, and a wonderful afternoon. Cheers.